Yeah, so good evening, everyone. Can you please confirm, am I audible or not?
Yes, sir, you are audible.
Yeah, thank you, Nishan. Thank you, guys. Thank you, Arviv. And you can see my slides also, right?
Yes, sir.
Okay, thank you. Yeah, so once again, good evening to our PMRF NPTEL Teaching Assistantship session. This NPTEL session is NOC 25C30, which is Geotechnical Engineering to Foundation Engineering. Myself, Rituraj Singh Surawat. I am currently acting as a Prime Minister Research Fellow in Department of Earthquake Engineering, IIT Roorkee. This course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering, IIT Kharagpur. So, those who are joining this session for the first time, let me tell you what these sessions are meant for. So, these sessions are the interactive session where we interact with our learners. So, usually the NPTEL sessions are the recorded sessions where the learners usually learn through the recorded lectures, and they are not having any platform to have a live interaction with any of the tutor or let's say the teaching assistants. So these sessions are designed in such a manner so that the learners can interact with the uh, learners can interact with the TAs and can discuss their doubts if they have any. Here we'll be discussing some of the important concepts which is required to solve the assignment problems. Also, we'll be solving some of the sample questions which will be helpful for you to solve the assignment questions, and we'll be solving some of the doubts related to your particular course or let's say your sample questions. And if you have any other technical query, please feel free to discuss, or if you want to discuss any general thing related to the course or the career guidance, we can help you to whatever extent it is possible. So try, please feel free to interact with us and ask your doubts if you have any. So let's start with our session today. This week's session is currently being for revolve around like addressing the queries related to the earth pressure theories. So here we'll deal with some of the sample questions which are related to the earth pressure theories. So let's come to our question number one. So I think this question has been addressed in the previous lecture also. So here you need to tell an unsupported excavation is made to the maximum possible depth in a soil which is having a gamma as 20 km per meter cube, C dash as 45 kPa, and phi dash is equal to 30 degree. You need to analyze the maximum possible depth of the excavation. So let's check this question. So the correct answer is 15.5 meter. So like what this question basically represents. So let's say if you are having a certain soil mass available to you, or let's say if you are having any particular ground, and these are the particular properties given to you, which is gamma is equals to 20 kilonewton per meter cube. Your C dash is 45 kPa. Your phi dash is 30 degree. So let's say if I want to make a excavation in this particular ground, so what is the maximum possible depth which we can achieve? So the h is given by 4c gamma under root ka, where your 4c is your 45, gamma is your 20 kilometer per meter cube, and yeah, k you can calculate using the phi dash, which is given by 1 minus sine phi upon 1 plus sine phi. So sine phi is 1 minus sine 30 upon 1 plus sine 30. So it's given by 1 plus 1 by 2, and your Ka is 3. So 1 plus sine 30, 1 minus sine 30, sorry, 1 minus 1 by 2. Where I'm making mistake?
It is 1 by 3, sir.
Yeah,
Answer.
yeah, sorry. So again 2 minus 1, 1 by 2, 3 by 2, 2, 2 is 1 by 3. So gamma is k is 1 by 3. So the correct answer is 15.55. I guess if you'll put this value, it's 15.55, right? 15.55 meter. Yeah, so the correct answer is 15.5 meter. So that was like a direct calculation from the formula given. Now let's move to our next question. So for the data given in the question number 1, so the active earth pressure in kPa according to the Rankine theory. So you need to use the Rankine theory and need to calculate what is the active earth pressure at the base level of excavation. So in question number 1, you need to calculate what is the active earth pressure as per the Rankine theory. Okay, one of the answer is A, question number 2A. So you can take this value. So gamma value is 20 kilometer per meter cube, C dash is 45 kPa, phi dash is 30 degree. So let's check the answer. Answer is 51.3, what we have from our learners. Let's answer is A. So your Rankine theory at the base level of acceleration. So it's basically given by gamma sc k minus 2c underscore root k, right? So your gamma is given as 20, your sc value you have evaluated here, it's 15.5, k value is 1 by 3 minus 2, cohesion value you know is 45, and your k value again is 1 by 3. So your active earth pressure is given by 20 into 15.5 into 0.33 minus 2 into 45 into under root 0.33. Yeah, so something I'm getting it as 50.59, which is approximately, which is among all these four options is 51.3. So yeah, your correct answer is A, 51.3. So let's move to our question number 3. So here you need to calculate the depth of tension crack. So retaining wall which is having a height of 6.5 meter, the smooth backfold retains a clay backfill with C dash of 15 kPa, pi dash of 30 degree, and gamma of 18.5 kN per meter cube. What is the depth of the tension crack? correct answer is 2.8. So again, it's straightforward. So let's say if you are having a certain wall system, or let's say if you are having a certain ground, yeah. So usually, like in the cohesive type of ground, your this particular top mass will try to go here, means it will try to fail. So if you see the stress condition which we are having here, above you are having a certain zone of active, and then you will be having a passive zone. So this usually the tension crack, this is the tension crack. So if there is certain part, let's say, which is going in the tension, so you need the equivalent mass to balance that. So this is the total height which you can excavate, let's say, as C, and this is the particular development of the tension crack. The tension crack depth uh, is given by 2c gamma root k, which is basically your half of the maximum possible depth of excavation. So let's say in the previous question, okay, the data is different, so we can use this. So your k value is 1 minus sine 30 upon 1 plus sine 30 is given by 1 by 2, 3 by 2 is given by 1 by 3. So your cohesion is 2 into 15. Your gamma is 18.5 into root k, which is given by 1 by 3. So it is 15 into 2 is 30 divided by 18.5, answer divided by root 0.33. So yeah, the correct answer is 2.82 meter. So the depth of the tension crack is D, is 2.82 meter. So again, it's straightforward. These all formulas have been derived by like if you go to the Rankine theories. So for balancing the soil mass, let's say if it's having a certain cohesive nature, so if you derive that, first you will get the tension crack depth, and then to balance the mass which is in the active zone, you need a certain mass to be in the passive zone, and that tension crack depth is given by 2c by gamma root k, so which is 2.8. So let's move to the question number 4. So for the data given in the above question number 2, the total active thrust on the wall after the development of the tension crack is. So the whatever data is given in the question number 2, you need to calculate how much is the total active thrust on the wall. Which is developed after the tension crack. So you need to calculate the equivalent force which has been generated due to the development of the tension crack.
Sir, can we see the data of the question too?
Yeah, I'll share. Okay, the question number 2 data is question number 1 data. Yeah, so you can take it from here.
Excuse me, sir.
Yeah,
In this question, height of the wall is not given. No? First question.
yeah, so I think we can
Without height, we cannot.
calculate this. Question number 4, for the data, the total active thrust on the wall after the development of. So you have been asked to calculate the active thrust, right?
Yes, sir.
Yeah, so do
For
you
thrust, we need the total height.
but for the active thrust, do you need the whole total height? Is it?
Yeah, yeah.
Mm,
Because it's the area of the entire diagram.
okay, the total active thrust. So let me check with the wall height.
Yeah, check, sir, please.
Uh,
Can you check the question number 2, whether you have given any height of the wall?
no,
The
it's
data
not
given.
given. No.
Then you need to give, sir.
Hmm. Okay, I guess it's not question number 2, it's question number 3 for the data given in the above question number 3. So you need to take the data from question number 3. Sorry for that. So I'll just change the question. So yeah, for the data given in the question number 3, so you can take this particular data. A retaining wall 6.5 meter high with a smooth backfill retains a clay backfill. Yeah, so let's check the answer. Answer is 42. So at the top, you know, the tension crack is having the width of equal to minus 2c gamma root k, sorry, 2c root k. So on the top you are having minus 2c root k, and this is your total depth is 6.5. Again, the depth of the tension crack which we have calculated in the previous question is 2.82 meter. So this depth which has been formed is 2.82 meter. So accordingly we can evaluate how much is the stress available in this particular block, how much is the stress available in this particular block, and then we can calculate this. So let's say at z equals to 0, where your z is this particular coordinate taken from the ground level. So at z equals to 0, you are having the total stress available at top is minus 2c root k. So your PA is equals to minus 2 C is your 15 kPa, and K value is 1 by 3. Similarly, this width minus 17.23 kPa, so at z equals to 6.5. So if we see from the similar triangles, so this is 2.82 meter, total height is 6.5 minus 2.82, it's 3.68 meter. So at z equals to 6.5, so it's minus 17.23 by 2.82 upon 3.68 upon P2. Your P2 is given by minus 17.23, or let's say if I remove the sign, because here it will get changed, so 3.68 by 2.82, so that will be your 17.23 into 3.68. Answer divided by 2.82 is given by 22.48 kPa, right? Yeah. So your P1 is 17.23, your P2 is 22.48. So now let's calculate how much is the total force. So we need to take the area of this stress block, which will give you the how much is the total force available. So on the wall, so the total active thrust, So the total active thrust is given by
Neglect the tension zone, sir.
yeah, we need to neglect the tension zone, right? So this part, like anyway, this soil block is not contributing uh, in providing the resistance to the wall. So only this part is contributing towards resisting the wall movement. So that's why only this stress loss diagram we need to take to calculate how much is the total active thrust which is acting. So the total active thrust is given by half into 3.68 into 22.48, which is given by zero point 0.5 into 3.68 into 22.4, which is given by 41.36 kilonewton. So that is 42 kilonewton per meter. So the correct answer is option B, 42 kilonewton. So let's move to question number 5. So in question number 5, this question is meant for a high retaining wall. It's having a smooth vertical bake face which retain a layered horizontal backfill. Top 2.5 meter thick layer of the backfill is sand having an angle of internal friction angle 30 degree, while the bottom layer is 2.5 meter thick clay with cohesion of 17 kPa. Assume a unit weight of both for both sandy clay is 18.5 kN per meter cube. The active pressure at the bottom of the retaining wall is. So you are having a 5 meter high retaining wall which is having a smooth vertical backface which retains a layered horizontal backfill. Top 2.5 meter thick layer of the backfill is sand which is having an angle of 30 degree, while the bottom layer is 2.5 meter thick clay. Cohesion is 17 kPa. Assume unit weight for both sand clay as 18.5 kN per meter cube. You need to evaluate how much is the active pressure at the bottom of the retaining wall. So this is a stratified soil layer case where you need to calculate the active pressure at the bottom of the retaining wall. So let's calculate how much is the active pressure at the bottom. So if you are having this certain soil system, soil layer, so this is a part. So your K value is given by 1 minus. So it has been asked because it is a stratified layer. So on the top you are having a certain earth pressure, and at the below layer you are having a different earth pressure. Yeah. So since in the top you are having a sandy soil, right? So here when you will calculate, so the earth pressure theory, the pressure, active earth pressure will be different P1, but when you will calculate at the bottom, here you are having the participation of the clay soil. So definitely the active earth pressure at the bottom of the retaining wall you need to calculate as per the clay soil calculation. So which is given by, so here your gamma value is 18.5 kilometer per meter cube, your C value is 17 kPa, and the total height is 5 meter. So here it is 2.5 meter, and this one is 2.5 meter. So for the calculation of what is the active pressure available at the bottom of the retaining wall is given by 2c, sorry, it's k gamma into z minus 2c under root k. So K value you need to evaluate with the available friction angle for the second layer, which is phi equals to 30 degree. So 1 minus sine phi 2, 1 minus sine phi 2. So again this is a clay soil, so your phi is 0. So 1 minus 1 minus 0 is your 1, and definitely that's why your 1 into gamma is given as 18.5.
Sir,
Yes,
bottom layer Ka is 0.
it's 0 1.
It is not given, no, therefore it is 0.
No, but if you calculate this particular formula, so
Yeah, 1 minus sine 0 by 1 plus sine 0 is 1.
yeah,
Friction angle is given for only for top layer.
yeah. So assuming that this is a pure cohesive soil,
Yes, sir.
so your sine phi is 0, sine phi is 0,
Yeah, Ka is highest value, you get 1.
1. Yeah. So I have written 1, right?
Okay, sir, done. But in the diagram we have made a 30 degrees, that's why.
Oh, sorry. Yeah, sorry. 1 minus. So with the data like I have derived from that, so it might be 1 minus. So Z is your 5 meter. So you need to calculate how much is the active earth pressure at the bottom. So total height wall is 5 meter, and then you need to evaluate 1 minus, so 18.5 into 5. Your cohesion value is 17 kPa, and your K value is again 1. So I guess 18.5 into 5 minus 34. So this is 58.5 meter. So the total active earth pressure at the bottom of the retaining wall is 58.5 meter, and the correct answer is D. Yeah. So here you can observe like we are not taking the participation from the sandy soil while calculating active earth pressure. So this clay soil is
The
having,
unit is wrong.
Oh, sorry. So its active earth pressure is 58.5 kPa. I'm so sorry. PA is equals to 58.5 kPa. Huh.
So,
Yes.
so I have one doubt. In lecture series, when the sir is solving similar type of a problem,
Mm-hmm.
where there are two cohesionless soil layers are taken,
Mm-hmm.
okay, there they have not considered this decrease in pressure. They have assumed the pressure is uniform.
Yeah.
Why
Yeah.
this?
So
So,
in this particular case, you are having a cohesive soil. So
hmm,
if you would have gone through the lectures, so the cohesive in the cohesive soil, you also have some formation of the tension zone.
yes, yes.
So you need to reduce that particular pressure which is happening due to the tension zone.
Yes, that I agree that.
Huh.
But in one question where there are cohesionless soil is taken, C
Mm-hmm.
is 0, phi is 30 degree and 35 degree.
Mm-hmm.
Gamma is 18 and 19 degree
Mm-hmm.
kPa.
Yeah, so in cohesionless soil, since there is no cohesive soil available, so in cohesionless soil, you don't have any formation of the tension zone. So
Okay.
whatever earth pressure is available, like your whole soil block will participate in giving the lateral pressure to your retaining wall, right? So
But
that's
the
why.
friction angle is different. So there might be some change in pressure, no?
Yeah,
Sir,
so
can I interact, sir?
yeah, please.
Any objections, sir? Can I interact?
Yeah, yeah, please go on.
Hmm.
Yeah, I think this question is asked by Nishant or who?
Yeah, Nishant.
Yes, yes.
Yeah, there was a mistake actually when faculty was solving the question in the videos.
Mm-hmm.
At the junction, when you have a two different Ka values, the pressure also varies.
Yeah.
But sir
Ah,
has taken only common answer and then he plotted
yes.
uniform diagram. I
Okay.
raised that complaint actually.
Okay, is it?
Yeah,
I
it was
Okay.
there,
I
sir.
thought
There was a
like
mistake.
the reduction in the tension zone has not been taken
No, no,
mentioned in
tension.
the question.
The question is not related with the tension, sir. Actually, he has given both the layers are sand and sand.
Yeah, yeah, yeah. So
But only at the upper layer, phi value is different, lower layer, phi is different.
hmm.
Yes.
Therefore, at the junction, you get it two different pressures.
Yeah, definitely.
But
Yes.
So
SAR has taken only one pressure, common pressure, around 24
Ah,
kPa or something he has
okay,
taken.
so he has taken the linear variation throughout the whole.
yes,
Yeah,
yes.
he forgot maybe he has forgotten to take
Okay, okay,
both
okay.
K
Yeah, yeah.
values.
No, no. Then that you need to take into account because I
Uh,
guess then the stress diagram in that particular case, if I take.
actually, both two different values will come at the junction, as Nishant told that.
Yeah, yeah. So
Yes. Yes, I
you will
agree
have something like
with
this
Arif.
formation which will be there.
Yeah,
So
either like that or even less also possible, depends
yeah,
upon the
less also
area.
possible. Yeah,
Yes.
That's all, sir. This question.
yeah. Yeah. Sorry, I haven't seen those particular lectures, so I
Yeah,
need to
I
go
have
through
seen.
them.
That's why I'm interfering here.
Yeah, please. Thank you so much. Yeah,
Thank you, sir. Thank you.
thank you for
Thank
this.
you.
Nishant, is it okay?
Yes, yes. My doubt
Okay.
is clear. Thank
Yeah,
you.
Yeah. Okay.
thank you, ARV. Thank you so much.
Thank you.
Yeah, so that's why these sessions are meant for the interaction. So in case like if I couldn't able to contribute, like anyone can volunteer to participate in this. Thank you, ARV, for your participation. So let's move to our next question, question number 6. So for the data given in the question number 5, the total active thrust per unit length of the wall you need to calculate. So you can take this data. Question number 5 data, and this is question number 6. Yeah, so the correct answer is 107.6. So let's look to this question. So this is a similar question. We have drawn a stress diagram here. So at the bottom, if we see, so in this particular case, yeah. So in this, your stress diagram basically looks something like this. So above you are having a sandy soil, then there is a reduction in the stress due to the formation of the tension zone in the clay soil. Oh, and then you will be having certain like pressure diagram like this. So the value which is available at the bottom is 58.5 kPa. Then your PA2 is like how you will evaluate it's by using the same formula. It's Ka gamma into Z minus 2C root over K. So your K2 will be given by, it's the same for the clay soil. So it's 1,
It is one, sir.
1, and your gamma is how much? 18.5, right? Yeah, it's 18.5, and then your Z2, Z
2.5.
2.5 minus 2, C is 17, right?
That
K
is zero, sir. First layer. Now you are taking. Yeah, you are taking first layer, second layer.
second layer, this
Okay,
value,
okay.
this
It's
value,
okay,
right?
sir. It's okay. Square root of 1.
And then you are having square root of 1. So this is gamma value is 18.5, right? So
Yes, sir. Same it is.
same it is, right?
Hmm.
So 18.5 into 2.5 minus 2 into 70. So this PA2 value will be
2.5.
12.25 kPa, right?
Yes, sir.
Yeah, so this is your 12.25 kPa, and then this value we need to evaluate. I think we have already calculated this. No, so this is K into gamma into Z. So for this we need to calculate. So this is PA2, let's say, and then this is PA2 dash. So your PA2 dash will be K1 into gamma into Z. K1 can be calculated here. Your K1 value is 1 minus sine phi value is
30 degrees.
30 degree, right? And this is 1 plus sine 30 degree. So it's 1 by 3. So K1 minus 2C root.
No question, sir. First
Oh,
layer.
sorry. It's 1 by 3. Then your gamma value is 18.5, right?
Yes, sir. Same.
And then Z value is 2.5. So your PA2 dash value is 0.33 into 18.5 into 2.5, which is given by
Both.
15.26 something, right? Yeah. So this PA2 dash value is 15.26 kPa. This value is 2.5 meter. This value is 2.5 meter. So now let's calculate the total force. So the total force will be the area of this stress block diagram. So total force is given by half into 2.5, and then this value Pa2 dash is
15.2
15.26, and then
into, sir, not plus, sir.
sorry, this is 15.26,
Yeah.
then plus, then this is a trapezoid, so half into the total height is 2.5 meter, and then you are having sum of parallel sides, which is 12.25
Yes.
plus 58.5, right? Yeah, so let's calculate this. So it's 0.5 into 2.5 into 15.26, it's 19.075 plus, then you're having 0.5 into 2.5 into 12.25 plus 58.5. So this is your 88.44. So plus 19.075. So the total force which has been evaluated here is 107.5125 kilonewton, right? So how much we are getting? Yeah, it's 1.076. So somewhere here. So this is the correct answer. Uh, so the main challenge in calculation of this type of question is like to obtain a proper stress diagram. Once you get the proper stress diagram, then you can get the corresponding total thrust which is acting on the retaining wall, as well as you can also get your line of action where the total force is acting. But obtaining the thrust diagram or the stress diagram is very important. Like you need to see where the stratification is changing, and if the stratification is changing, then during that change in stratification, what value of the stress point you need to take into account, so it becomes important. So any doubt in this? Yeah, if not, so then let's move to our next question. So this is question number 7. A vertical cut in purely cohesive soil failed when the depth of the cut reached to a depth of 4.6 meter. The expected value of the cohesion of the soil, assuming unit weight of the soil is 18.5 kN per meter cube, is. So you are having a pure cohesive soil. You have a vertical cut in that particular soil. When the depth of the cut reached to a depth of 4.6 meter, then the expected value of the cohesion of the soil, assuming unit weight of the soil as 18.5 kN per meter cube, is. Yeah, so you need to calculate the expected value. So yeah, this is the reverse calculation you need to perform. So I'll just be back within 1 minute.
Tell me, please. You are from which branch, sir? Okay. Okay, sir. Everything is fine, sir. There's no any much problems. I couldn't remember, but we got it in almost within the limits only. Next time I will note down in the calendar and I will inform you. Yeah, it was completed in Tanuja. Hmm. Yeah, yeah, I received and you also got it now. Oh, what is that? What is that?
So let's look to this question. Yeah. So the expected value of the cohesion of the soil, assuming, so the total vertical cut which we can make is 4c by gamma root Ka, right? Your K value, so it's a pure cohesive soil, so your K value is 1. So your cohesion is H into gamma into root Ka by 4. Your H is 4.6 meter, gamma is 18.5, Ka value is 1, and then you are having 4. So the total cohesion value which is calculated is 4.6 into 18.5, answer divided by 4. So its cohesion value is 21.275 kPa. Yeah. So the correct option is option B, question number 7. Then let's move to question number 8. This is straightforward question, so I don't think we need to check in this. So the passive earth pressure at the top of the retaining wall. So just let me check. Is it following the same question? 4 HP. Yeah, 4. Yeah. So this is the same. Like you need to take the data from question number 7 only. So how much is the passive earth pressure at the top of the retaining wall? So till now we were dealing with the active earth pressure. Now we need to calculate how much is the passive earth pressure.
Sir, is it the same question or
Yeah, yeah, it's the same
data?
question. Yeah, this data you are putting.
Okay. Show me it, sir, for some
Yeah, sure.
time
So
data.
the,
What are the options, sir?
Yeah. Yeah, we'll check the answers. So the passive earth pressure at top of the retaining wall is 58.8 kp. How much are you getting? It's 40.6
What is the question, sir? Can I once again?
data.
The passive earth pressure at the top of the retaining wall.
Yeah,
And what is the data? Can you write here only data, sir?
yeah, I'll do that.
Okay.
Mm, the pure coaxial, the depth. So the expected value of the cohesion soil. So
C is
C,
available in the answer
yeah,
actually.
C is
21,
21.2 kp.
21.2. Yeah, that is enough for us.
Yeah, yeah. So let's say for the passive case, the passive earth pressure which is calculated is given by 4h into kp, or like let's say 4z kp plus 2c root over kp, right? So
Sir? Yeah.
yeah, for the passive earth pressure. So
Yes,
earlier
sir. Yes, sir.
for the active it was minus.
Kp into gamma into Z. Why 4 you have written, sir?
uh, 4
Kp
k.
into gamma into Z, na?
So how, what was the value of that? Yeah, it's gamma.
General formula.
German formula is gamma
Hmm.
z into, so gamma multiplied by
Kp.
kp. Yeah.
Yeah, now it's
So the
Z is
passive,
0.
yeah, z is 0 and this value is 2 into cohesion value is 21.2 and kp value again it's 1.
1.
So the correct answer is 42.4. 2 into 21.2, 42.4. So is any
I
option D?
also got same answer.
Is it
I have selected close to the option D.
option D, right?
Yes, sir.
Okay.
But you have mentioned 58.8. I am worrying how it is.
Yeah, so might be I've taken this question. Yeah. So let me check the questions which you have framed. I guess there is some
As
problem.
per seventh question, this answer is correct, sir.
Seventh question. Yeah, then let's go for that. So might be the options which we have framed is not in the correct option. So yeah, the passive earth pressure is 42.4 kp at the ground.
Done.
Okay. I'll just remove the option from the document. It's question 7, question 8. Or I'll make this as 42.4. Or I'll make C as 42.4. One second. So yeah, your C option.
Screen shares.
Yeah, sure. So correct answer is PP 42.4 kp. Then let's move to our question number 9. Okay, I think I have not given the data corresponding to the question number 8 and 9. So these were the part of any particular question. So you can take the corresponding data. So here the height of the wall which is available is 5.5 meters, and your phi value, like it's a sandy soil, is 30 degree, and then the gamma value which is there is 18.5, and then the cohesion value is 70. So let me check with the question again. 4.6. So the data here 8 9. So the total height is 5.5 meter. Your phi value is 30 degree, gamma value is 18.5, and your cohesion value is 17.
Earlier you have given phi is equal to 0. Now you are changed it to 30. Is it okay, sir?
Yeah, this is a new data for this question.
Okay.
uh, so your C value is 17 kp. So let's say this is a certain wall system where your total height of the wall is 5.5 meters. Then the soil is having a friction angle of 30 degree, and your gamma value is 18.5 kPa, sorry, kilometer per meter cube, and then your cohesion value is 17 kPa. So
Answers will not match, sir. You
why?
get new answer.
No, so this is the data for this question number 9. So I think then you should get one of the corresponding answer in this. So here your Kp value is given as 1 plus sine 30, 1 minus sine 30, so it will be 3 because it's 1 plus 1 by 2, yeah, 1 plus 1 by 2, 1 minus 1 by 2, so this will correspond to 3. Again your, so the passive earth pressure, so pp is given by h gamma root, sorry, h gamma ka plus 2c root ka, right? Yeah,
KP sir, not KM.
yeah, it's kp, sorry. H gamma kp plus 2c root kp. So your total height of the wall is 5.5, gamma value is 18.5, and kp value is 3, plus 2 cohesion value is 17 kpa, and then you are having root of kp which is 3. So the answer which you will get here is 5.5 into 18.5 into 3 plus 2 into 17 into root 3. So the correct answer is 364.14 kPa. So question number 9 is having answer of 364.14 kPa. Now let's move to question number 10. So the total force on the wall just before the failure is. So you need to calculate how much is the total force which is acting on the wall before the failure is happening. Okay, so for that question also your data will remain P1, P2. Actually, I have not framed this question, so I think the another T has framed, and there are some, they have not given the proper data, so need to check that. The total force on the, so yeah, this is a part of the previous question only. So the height of the wall is given to you, your all the data is same. Okay, so 8, 9, 10 question was of same. Yeah, so you can skip the 10 question for the time being, some data is missing. So let's move to question number 11. Yeah, a retaining wall, it's having a height of 10 meters of a smooth vertical surface. Layer 1 is of 0 to 4 meters, c is 0, phi is 30 degree, gamma is 16 kilometer per meter cube. Layer 2 is 4 meter to 10 meters, c is 0, phi is 25 degree. So this is layer 1 details, this is layer 2 details. You need to neglect the water table effect and using Rankine theory you need to calculate how much is the total active pressure which is acting on the wall. So is it not in the option ARV?
Sir, I got 325. I will once again check it.
Yeah, let me also calculate this. So the correct answer which I am having right now is 200.1 kPa, kilometer per meter. So so the wall system which is given to you is having a soil system which is of the stratified layer. So this is layer 1. So the total height of this layer is 0 to 4 meter. Your C value is 0, phi is 30 degree, your gamma value is 16 kilometer per meter cube. Here you are having C as 0, phi as 25 degree, and gamma value as 18 kilonewton per meter cube. Okay, so the layer 1 is 0 to 4, and this is having 4 to 10 meter, right? So the stress block which is available here is, first you are having the lateral pressure from the layer 1, then there is another lateral pressure from layer 2, and then this is another lateral pressure. So here you are having P1, then you are having P2, and then you are having P3. So what is this? Let's assume that a small P1, this is small P2, and this is small P3. So the small P1 will be K into gamma into Z. So the K1 value is given by 1 minus sine phi upon 1 plus sine phi. So 30 degree as we have already calculated, so this is 1 by 3. Then for the calculation of K2, it's 1 minus sine 25 degree upon 1 plus sine 25 degree. So the value which I am getting it as 1 minus sine 25, answer divided by 1 plus sine 25. So it will be 0.41, and here it's 0.33, right? So P1 value is your K1 into gamma Z, so that is 0.33. Gamma value is 16 km per meter cube, and your Z value, the total height of the layer, is 4 meter. So it is 0.33 into 16 into 4, so that is 21.12. So okay, it has been asked to calculate only the pressure, so we don't need to
Pressure.
calculate.
Kilopascals.
So it's kilonewton per meter. Then do I have one more side? Yeah. Now calculation for the P2. Okay.
Sir, you will get the two P1 values. One more will come at the word or the top of the second layer.
Uh,
You will get another value, sir.
Sir,
It is
that's
not a
what I
continuous.
was asking.
Yeah, yeah. You are
Okay.
asking that. I remember.
yeah. So I
At
was
the next.
saying means here means we'll be having the another value, right?
Yeah, yeah, yeah. Because of
Yes,
KA
Yeah.
difference.
Yeah.
there will be two values.
Yes. Now it is correct.
Yeah.
Now it is, yes.
Now it is correct.
Okay. Yeah. That's how it should look like.
Yes, sir.
Yeah. P1. So let me tell this as P1 dash. Hmm. Yeah. So now with this diagram, you are getting the correct answer, right?
Yes, sir. Yes, sir.
Means whatever answer you are getting from this diagram.
Hmm.
Yeah. So
Yes.
Diagram is
I
correct
think
now. We need to calculate once again.
yeah. So I think there is some issue with the, like, someone else has framed those questions, so I'm so sorry for that. It won't happen again. But
It's okay, sir. It's okay. Go ahead.
so okay, we'll proceed with this. No worries. So P1 value you know is 21.12 kN per meter. Then let's calculate the P1 dash. So the P1 dash is given by,
Ka2 into gamma,
yeah, it's K2 into gamma.
gamma 1,
Gamma 1 will be there in the account, and then you'll be having the
Z1.
Z1, right? So your K2 value, it's 0.41, right?
Yes, sir.
It's 0.41.
Into 16.
Gamma 1 is 16 into Z1 is
Into 4 meter.
into 4. 0.41 into 16 into 4, that is 26
5.6.
to
Yeah.
4 kilometer per meter, right?
Yes, sir.
Then you are having P2 dash, not P2 dash, it's P2. So your P2 value will be same as P1 value, so that is 21.12 km per meter. Then you are having P3 value,
Sir, what is the 21 point?
12 km per meter. So the this will be same, right?
That is upper layer, no, sir.
Okay, no, actually I have divided these two parts. So yeah, but then since it's the linear behavior, so you will be having only one value here. So let's take it as P2. Then in this particular case, okay, this is P1 dash, P1 dash, P2 value will be K2 into gamma 2
It's a
into,
cumulative, sir. Gamma 1 Z1 plus gamma 2 Z, bracket in bracket.
yeah, it's first you need to take this uh, K2 first you need to take the stress block diagram for this. So this will come gamma 1 into this one Z1, and then you will be having the gamma 2 Z2, right?
Plus Ka2 into gamma 2 Z2. Otherwise, gamma 2 Z2. That's all.
Yeah, so it's 0.41 into gamma 1 is 16, Z1 is 4, plus gamma 2 is how much? 18.
Yes, sir. 18 into 6.
18 into 6. Yeah, so it's 16 into 4 plus 18 into 6, answer into 0.41.
Approximately 69.
Yeah, 70.52 I'm getting, something like this.
Yes, sir.
Yeah, so they are asked to calculate the total active pressure on the wall. So the total active force will be there, how the pressure they are calculating. So in kilometer per meter, so if I'll multiply with the height, so this should be the total active force, right? It shouldn't be pressure. So in that particular case we can take the area. So first, total force is equals to half. So the total height of the first stress block is 4 meter. Is a 4 meter. and then your P1 value is
21.1.
21.12. Then we are having total force, then plus your this area we need to take into account. So this will be your half into sum of parallel sides, which is P1 plus P1 dash. So it's 21.12 plus 26.24. Then you need to take the bottom side, which is P2 value is 70.52, half into sum of parallel sides, and the total height of the second stress layer is 6 meter.
So you don't have a three here. 21.2 is not there. It's already 26.
No, it's P1 dash we have calculated, right? This value. Okay, it's the
Hmm.
total value. Sorry.
Only two answers
Yeah,
there.
yeah, yeah. So that is P1 dash. Right. It's P1 dash. Yeah.
No 21.12. Okay, removes. Yeah, that sounds.
Thank you so much, Harry.
Welcome, sir.
Half into 4.5 into 4 into 21.12. It's 42.24. 26.24 plus 70.52. Answer into 6 into 0.5 is 290.28. So plus 42.24. Yeah, so you are getting something like this, right? 332.52 kilometer. How much you are getting? It's 325.8. Yeah, so more or less same. Mm. Yeah, so I think this is clear. So the question was asked like you need to calculate the total force which is acting on the retaining wall. So first you need to calculate the stress diagram which is happening due to the layer 1. Oh, so this is, you need to evaluate this stress magnitude value at the interface of these two layers. Then you need to take also the increment in the stress due to the layer underneath, so that you can calculate by considering the Ka2 value. Then you need to calculate the stress diagram, stress value at the bottom of the wall by considering the whole height of the wall and with the soil parameters of the layer 2, and then you can calculate how much is the total force. So this is 332.52 kilometer. So let's move to our next question. Yeah, so let me check this question whether it's correct or not. Oh,
Are you giving a data, sir?
yeah, I'm just checking. Actually, there were some glitches in today's questions, so I am
Yeah,
just making.
backfill properties are required.
Yeah. So I'm just making sure. Yeah. Yeah. So yeah. So I'll just draw the diagram. So let's assume that this is your retaining wall. It's having a stratified layer. This is the first layer. So here you are having the water table. Your G value is 2.65. Your E value is 0.65, and phi value is 30 degrees. So these are the properties which are same for both the layers. So here the total height for the first layer is 3 meter, and then this is the another layer which is having a height of 7 meter. So the whole domain is sandy soil. So you need to calculate how much is the total active thrust on the retaining wall. So a retaining wall with a smooth vertical bake retains a backfill. The total depth is 10 meter. Yeah, now I think the whole data is complete. Yeah, so this is the last question for today. Just calculate how much is the total active thrust on the retaining wall.
Sir, what is the below G, sir?
Yeah, so this is the homogeneous layer. Only you are having the introduction of the water table at 3 meter below the depth.
Yes, sir. Yes, sir. Below the G value, is it a void ratio or C?
Yeah, it's the void ratio.
How much, sir? 0.65.
0.65 and phi is
Okay,
50
okay,
degree.
okay,
And
sir.
yeah,
Okay.
there's one more parameter before you calculate. So you are also having a surcharge of 14 kPa. So 3 meter, 7 meter, you are having the two stratified layers. You are having the water table with you, and then uh, the properties are given to you. So it's same for both of them, and then you are having surcharge which is acting on the top surface, which is 14 kPa. ये फोन जो है देता हूँ वापस. Hello.
Sir, tell me, sir.
Yeah, it's fine. Like I was just checking my mic. Uh, Hello.
Yes, sir.
Yes. So guys, I think like this is a big question. Like if we'll solve, it will require 10 minutes. So we TAs are not allowed to take more than 2 hour session. So this time like we need to keep it in constraint. So maybe like we can continue this question in our next class, and
Sure, sir.
meanwhile you guys can also give a try on that, and then we'll discuss about this in the next class.
Yes, sir. I tried. I mentioned my answer. You can also check later, sir.
Okay, okay, sure. Thank you, Ari.
Thank you, sir. Thank you very
Yeah,
much.
yes, guys. So thank you for
Thank you,
joining.
sir.
Thank you for joining today. If you guys are having any doubt, like you can let's discuss in our next class, and those who are watching this video on the YouTube channel, you can post your queries on the comment section in the YouTube video, and one by one, like we can address that query, and yeah, that's it. So let's meet on next Tuesday at same time at 6 p.m. We'll continue with the question, this question, and we'll also solve some of the another sample question. Yeah. So thank you, everyone.
Thank you, sir.
Thank you, guys.